Hi everyone, in this video we will continue working on linear programming problems. In this video we're going to practice writing the objective function and writing the constraints. Okay, so this is a problem from page 408, it's number 6. The profit on a scientific calculator is $10 and the profit on a graphing calculator is $12.50. Write the objective function for the profit as a function of the number of scientific calculators sold and the number of graphing calculators sold. So first of all, we're told what the objective is. Okay, this is, we're writing a function for profit, and we know for profit, generally we want to maximize it, not minimize it. So that's the objective, maximize the profit. And then I'm told that this should be written in terms of the number of scientific calculators and the number of graphing calculators sold. So I'm going to let the number of scientific calculators sold be x and the number of graphing calculators sold be y. All right? And then what I need to do is just write the two profits that are associated with those. So this is a standard form equation. Okay, it's like ax plus by equals c. Only in this case I've just switched it around. Okay, so I've written this as like c equals instead. And instead of a c, I've used a p. Okay, just to emphasize the fact that this is profit. So basically the total profit has two parts to it. It's got the profit from the scientific calculators and the profit from the graphing calculators. Okay, so it's going to look like something x plus something y. And then I just need to fill in the numbers. Alright, so profit for scientific calculators is $10, so it's $10 per calculator times x, however many calculators there are, and then plus $12.50 per each of the graphing calculators, okay, times y, times however many calculators there are. You can fill in dollar signs if you like, just to remind you that these are profits, okay, or you can leave those out. And that's the objective function. Here's another one. This is page 408, number 16. The profit on a pedal exerciser is $14.60. The profit on a total body exerciser is $35.45. Write the profit function as a function of the number of pedal exercisers sold and the number of total body exercisers sold. So again, I like to just go in order of how these things are mentioned in the problem. So we have pedal exercisers, I'll call that x, and body exercisers, y. And then I want to know what the profit is, so I have a piece of profit that comes from the pedal exercisers and another piece, a certain dollar amount, that comes from the total body exercisers. So then I just need to go back and fill in the profits for each. So it's $14.60, and you can even leave the zero off if you like, $14.60 per pedal exerciser, and $35.45 for each total body exerciser. And that's it. Okay, constraints. So we need to look for the limitations or the restrictions and try to describe them mathematically as inequalities using either less than or equal to signs, greater than or equal to, or just strictly less than or strictly greater than. So here we have a food store owner buys turkeys and hams. The owner plans to purchase at most a total of 50 products. Write a constraint. Alright, so we have two things here that are involved. We have turkeys and we have hams, and we have at most a total of 50 products. Alright, so basically all together the turkeys and the hams, should be at most 50 of them. Okay, well, at most, that's one of those key phrases that indicates an inequality. So we would have turkeys plus hams is less than or equal to 50. Right? And then what I really just need to do here are use variables instead of turkey and ham. So I'm going to use x and y. Right. Somewhere in this problem, I probably, before I even got to this point, I would already have made a key, and in that key I would have said which is which. Okay, so x is maybe turkey, y represents ham. Okay. Now for these types of problems, this one just says write a constraint, but get used to writing the implied constraint as well. So we have a couple more that just describe the minimum of these turkeys and hams. Okay, so in every problem, we're going to be only working with positive or zero valued variables. So we need two statements here to say that the number of turkeys has to be greater than or equal to 0, and the number of hams has to be greater than or equal to 0. Okay, we can't work with negative values for turkeys and hams. All right, let's try this one. The manager of a store plans to purchase at least 20 more desktop computers than laptop computers. Write the constraint. Okay, so here's this at least phrase, at least 20 more desktop than laptop. So let's let the desktop be x and the laptop be y. Okay, and then at least 20 more than. This is one of those phrases, more than or less than. Okay, more than indicates in addition to or an adding thing. If it was less than, it would be subtracting. All right, so we have 20 more desktop than laptop. Now, one common thing that students will mix up, a lot of people can see that this is going to be a plus 20, but they're not sure whether to put this with the x or with the y. So is it x plus 20 and y? Is it x and y plus 20? And then which way does that inequality symbol face? If it's at least 20 more than, is it greater than or equal to? Is it less than or equal to? All right, so if you find yourself getting confused with this, then what I like to do is make a little chart and look at some actual numbers. Okay, so I have x is the desktops, y is the laptops. Okay, and if it's at least 20 more desktop computers, then let's pick just some numbers here. So say it's 10 laptops. Now, temporarily, let's just pretend that this was exactly 20 more than, and this is going to help us decide which of one of these numbers gets the plus 20. All right, so 20 more desktop computers, then that would mean if there are 10 laptops, there are 30 desktops. If there are 50 laptops purchased, okay, then there would be 70 desktops purchased. Okay, so now think about describing these. Okay, well, it's this 70 number, okay, that's more than this 50 number, right? So this is like 50, and then this is like the 50 plus the 20. All right, so since since the laptops, the y is the smaller number, okay, then I have to add 20 to that to make whatever x is. All right, so if I was comparing this, okay, now if I write my equation, okay, so temporarily I'm just going to pretend that this is an equal sign. And so on one side, like let's say I have the 70 for the desktops, and over here I have the 50 for the laptops. All right, well, where does the plus 20 need to go? It's got to go on this right-hand side to balance this out. All right, same thing if I did the 30 and the 10. Since the 10 is smaller, that's where I need to put the 20 to balance this out. Okay, so it's actually the x is by itself, and then the y, the smaller number, gets 20 added to it to balance this equation. Okay, so now I know where the 20 goes, but now I need to go back and put in the correct inequality symbol. So it wasn't exactly 20 more desktop computers, it was at least 20 more desktop computers. So now let me think of some numbers here that actually truly reflect this. It's at least 20 more, so it could be 70 and 50, but there would be nothing wrong with doing a number greater than 70. So I could do like 80 and 50, all right, or 200 desktop computers and 50 laptops. All right, so now if I try to, write my equation, okay, I know that it's x and y plus 20. And now if I fill in one of these situations with the numbers, so let's say I choose, I'll put 200 in for x and 50 in for y. Right, so on one side of the equation I have 200, and on the other I have 70. Well, now I know which direction that inequality symbol should face. Okay, it's the 200 that's the larger one. Okay, so that's my suggestion. If you're not sure which direction the symbol should face, then try some numbers out. Okay, and look first at the situation where you have, instead of at least, if you have exactly whatever the situation is, and that's going to help you figure out where this plus 20 should go, or this, this other number that's involved. And then try to think of some other scenarios. If it's at least 20 more, then do 40 more, do 60 more, do 80 more, and hopefully that will help you figure this out. Okay, so there we have it. There's the constraint. All right, here's another situation. We actually have a couple constraints here. So let's read this through. It takes 3 hours to film a concert and 1 hour to edit the video. It takes 1 hour to film a wedding and 2 hours to edit the video. There are X concerts that need to be filmed and Y weddings. DeMarco does all the filming and Jasper does all the editing. Because they're interns, they can spend no more than 15 and 10 hours on their respective tasks. Write the constraints. All right, so first of all, a reminder here, respective means in whatever order it was given. So it was DeMarco doing filming, Jasper doing editing. So that means that 15 goes with DeMarco, and 10 hours is how much time Jasper can spend on editing. So let's look here at the limitations, and here's the restriction in this last sentence. Okay, no more than 15 and 10 hours on their tasks. Right? So the restrictions are on the filming, right, or DeMarco, his time. All right, so all of his filming, okay, has to be no more than 15. Well, how do I say that? All right, no more than is less than or equal to. Okay, and then Jasper doing the editing, the limitation on his time, it's no more than 10 hours. So he's got to stay less than or equal to 10 hours for all of the time that he's spending. Right. Now, what are the variables? Well, in this case, the variables are the number of concerts and the number of weddings. So this is a situation where we have constraints on something that's not the variables. So what we need to do is try to describe what does the time that DeMarco spends filming, how do I describe that in terms of X and Y? Right. Well, if I go back and look through for any information having to do with filming, I find a couple things. I see that it's 3 hours to film a concert and 1 hour to film a wedding. Okay, so there we have it. We've got the time for X, the concerts, and the time for Y, the weddings. Right. So this is another one of those standard form ones. Time spent on one thing, the concerts, plus time spent filming the weddings. And in this case, it's got to stay no more than 15 hours altogether. All right, so it's 3 hours per concert times X number of concerts. And he spends 2 hours, 1 hour. 1 hour for each wedding, filming that, times however many weddings there are, Y weddings. All right, how about Jasper? Same idea. Now he spends 1 hour editing the concert videos, and he spends 2 hours editing the wedding videos. So his time is 1 hour per concert plus 2 hours per wedding, and his time has to stay less than or equal to 10. Okay, so there are the two constraints. And then the implied ones, okay, we have some minimum values for x and y. There can't be negative numbers of concerts or weddings. So both x and y have to stay greater than or equal to 0. All right, that's some practice with writing the objective function and the constraints.